Graphing exponential functions. Exponential functions look like this down here below. Have an a to the x power. The x is the exponent. We're going to graph them today. Going to be some curves. All right, we're going to walk you through the first one here by making some xy values and see what the graph actually looks like. I'm going to start out by plugging a 0 in for x. Remember, 2 to the 0 power. Anything to the 0 power is 1. If I put 1 in for x, 2 to the first power is 2. If it's go -1, if I put -1 for the x, it flips it, which makes it 1/2. If I put 2 for the x, 2 squared is 4. And if I put -2 in for x, 2 to the -2 power, you would square and flip it, you would get 1/4. So I'm going to graph those points real quick. 0, 1 is about right there. 1, 2 is about right here. -1, 1/2, about there. 2, 4 is way up here. -2, 1/4. You can kind of see what the shape is doing right here. If I connect those, I get something like this. Connect the dots. La, la, la. What happens is, that's what the curve looks like. That's actually called exponential growth, to be honest with you. Anytime this number that you're being raised to, the x is being raised to, is bigger than 1, it's called exponential growth. It means the curve grows, increases as you go left to right. All right, let's look at one opposite. Let's look if it's less than 1. If it's less than 1, I'm going to do the same thing here. Make an XY plot here. Plug in 0, get 1 again. So anything 0 is 1. So this point, that 0, 1 point is going to be in just about every one that you do. Plug in 1, you get 1/2. If you plug in -1, it flips it. If you plug in 2, you get 1/4. If you plug in -2, it flips it. So 0, 1 is right here. 1, 1/2 is right there. -1, 2 up here. 2, 1/4, getting closer. -2, 4 way up here. So that graph is going this direction. Same kind of curve, going just the opposite direction. Notice it's decreasing as you go left to right. So when this number right here is less than 1, it's called exponential decay, which means this graph is decreasing. On the last slide, it went the other way. It was bigger than 1. It was exponential growth. All right, this slide right here has it all. I mean, if you want information on this stuff, this is it. Take a picture, do something. It's all here. Properties of exponential functions. First of all, they're continuous. What continuous means is there's no breaks or holes in them. Second thing is they're one-to-one. That means they pass the horizontal line test. Their domain, negative, they go left and right forever is what that's saying. Their range, it go from 0. Notice it doesn't include 0. The x-axis is an asymptote, and that's coming up in a minute. That's why the range is from 0 to infinity. It's increasing, which means it's growing if your number is bigger than 1. It's decreasing if it's less than 1. I just said this a second ago. The horizontal asymptote is the x-axis. It never touches the x-axis. It gets closer and closer. And the y-intercept is always 1. That's a huge deal as we start to graph these things. All right, this one says graph each of the following. We're going to do some rough sketches of these. I just want you to see what happens with these things. This first one right here has basically y equals 2 to the x minus 2. That's the same graph we did on the first slide, except it's been shifted right too, because we have an x minus 2 in our, the x is in, the minus 2 is inside, so it shifts it right too. So my point that's usually, at 0, 1 has been shifted to 2, 1. It's been shifted 2 to the right. Because it's 2, it's still growth. The x-axis is still the asymptote. It's just been shifted over a little bit, 2 to the right. So all the points I had earlier have been shifted 2 to the right. Let me change colors here. The second graph has 2 to the x minus 4. So same shape, but now it's been shifted down 4, which means my x-axis, which is the asymptote, is now at -4. That's the new asymptote. My point 0, 1, which is on all those graphs, is now that point right there is always still 1 above. It's always 1 above. It hadn't been shifted left to right, so it's still just 1 above. The graph's going to do this kind of deal. Same shape. And the last one here, let me change colors one more time. The last one is really, you can write it this way. 0.5 is really 1/2, so it's really like -1/2 to the x power plus 5. So because that number right there is less than 1, it's going to be, it would go this direction. It would kind of do this. All right, the plus 5 is going to make the asymptote come up 5. So there's a new asymptote for this one. And think about what the negative sign does. The negative sign reflects it across the x. So technically, if that negative wasn't there, my graph would look like this. It'd go 1 above right there, it would come right through here. I'm trying to draw broken, it would do that. But because the negative's in the front right there, it's been reflected across the asymptote or the x-axis, so the real graph does this. All right, so there's that. Got one more slide here. All right, compound interest, something completely different, but it is exponential, and it's a good lesson to have it in. It says, suppose, there's your formula, by the way. Make sure you get that down. That means your final amount of interest will be your principal, which is what you start with, times 1 plus R. R is your interest rate. N is number of times compounded. You should write that down. N is number of times compounded per year. Okay, that's important. Okay, now we can work the problem. Got to make sure, one more time. This number over here is how much number, the final amount. That's why the A is there. P stands for principal. That's the amount of money you start with. R is interest rate. N is how many times per year it's compounded. T is time. How long is it going to take? Okay, so part A. It says find the amount of money in the account after 4 years and 8 years, and we have $100,000. So the final amount is going to be 100,000 times 1 plus the rate. You got to change your rate to a decimal over N. N is how many times a year? It says semi-annually. That's twice a year to the NT power. N was 2, and T said 4 years. So I'm going to do 4 right there. So my exponent is really 8. So I'm going to take a second, punch this in my calculator. And when I punch it in, I get this. I get $129,157.75. You might want to punch that in your calculator too. Make sure you got the same thing I did. I'm not going to do the second part, but it says also 8 years. All I would do is I would take that 4 right there and change it to 8, which is going to change my exponent to 16. So I should have quite a bit more money. So that's making $29,000 in 4 years. That's pretty good. Okay, the second part says when will the money reach when will it reach 400,000? So what I can do here is I'm going to say, okay, the final amount's 400,000. We're starting with 100,000. And everything else is the same. 1 plus 0.065 over 2. And over here here's the difference. I got 2t. So what I'm going to do first is I'm going to move this 100,000 over and dividing both sides by 100,000. That gives me 4. I'm also going to work out what's inside my parentheses on my calculator. And when I do that, I get 1.0325 to the 2t power. Okay, when we get there, the only way to solve that without doing a graph is to actually do a log, which I haven't taught you yet. I know you've had them in the past, but I'm going to wait. And we're going to save this type of problem until after I teach you logs because they're so much easier than doing the graphical method. So I'm just going to wait. You do need to make sure you can do this one. And if we do see one of these in our assignment tomorrow, we will skip that and wait till we get to the log section because it makes it so much easier. All right. Hope that wasn't too bad. See you tomorrow.